Most people only use one or two Nmap commands, but Nmap has dozens of powerful options that can save your time during reconnaissance and penetration testing. In this video, I'll show you some important Nmap commands that every ethical hacker should know. Let's get started. Welcome back to Scrappy-Sec. If you're learning cybersecurity, penetration testing, or preparing for certifications like CEH or CPENT, this video is for you. Today, we'll go through some of the most useful Nmap commands, explain what they do, and show when to use them. Before we start scanning with Nmap, let's first make sure our target machine is reachable. Here I'm sending ICMP echo requests to my victim virtual machine at its IP address. The replies confirm that the host is online and ready for reconnaissance. Next, let's perform a full TCP port scan using the P option. By default, Nmap scans only the 1,000 most common ports, but adding P tells Nmap to scan all 65,535 TCP ports on the target. This is important because services don't always run on standard ports. Administrators may configure applications to use uncommon ports, and attackers often look for these hidden services during reconnaissance. Once the scan finishes, we'll be able to identify every open TCP port that Nmap discovers. In the previous scan, we identified the open ports on our target, including ports 22, 135, 139, and 445. Now let's take the next step by using the SV option. This command performs service version detection on those specific open ports. Instead of scanning every port again, we're focusing only on the ports we already know are open. Nmap will communicate with each service and attempt to identify the exact software and version that's running. This information is extremely valuable during reconnaissance because outdated service versions may contain known vulnerabilities that can be further investigated during an authorized security assessment. The scan has now completed, and Nmap has successfully identified the versions of the services running on each open port. Port 22 is running OpenSSH for Windows version 7.7, while ports 135, 139, and 445 are all Microsoft Windows services. Now, let's use the SC option to run Nmap's default UNSE, or Nmap scripting engine, scripts against the open ports we previously discovered. Instead of scanning every port again, we're targeting only ports 22, 135, 139, and 445. These default scripts automatically perform safe enumeration tasks, such as gathering additional information about the services, checking common configurations, and identifying useful details. The scan is now complete, and the default NSE scripts have gathered additional information about our target. For the SSH service on port 22, Nmap displays the host key fingerprints, which can be used to verify the identity of the SSH server and detect changes over time. The scan also confirms that ports 135, 139, and 445 are Microsoft Windows services. In the host script results, Nmap reveals the computer's NetBIOS name, along with SMB configuration details. It shows that SMB message signing is enabled but not required, which is useful information when assessing the security configuration of a Windows system. Now, let's identify the operating system running on the target using the O option. Since OS detection requires sending specialized packets, we're running the command with sudo to provide the necessary privileges. Based on the target's responses, Nmap identifies the operating system as Microsoft Windows 10 and even estimates the version range. It also reports the device type as a general-purpose computer and shows that the target is only one network hop away. Identifying the operating system provides valuable information for planning the next steps of an authorized penetration test. Now, let's run one of the most powerful Nmap commands by combining multiple options into a single scan. The iFlag enables aggressive scanning, which performs operating system detection, service version detection, default unse scripts, and tracer route all at once. The T4 option increases the scan speed, making it ideal for fast and reliable networks such as a lab environment. Finally, the O option saves all of the scan results to a text file named aggressivescan.txt, allowing us to review or analyze the findings later without running the scan again. Instead of executing several separate commands, this single command collects detailed information about the target in one scan, making it an efficient choice during the reconnaissance phase of an authorized penetration test. If this video helped you, subscribe to my channel, and I'll see you in the next one.